So now we have another disease that has an incidence rate of 2%. The false negative rate is 10%, false positive rate is 1%. So let's compute the probability that a person who tests positive actually has the disease. So there's two ways to do this. Let's start with the easy way, and that is to create a table. So now we got positive, negative, disease, no disease. Now, for simplicity, let's imagine that we have some nice round number of people. Let's go with something pretty big like 10,000 just to make sure our numbers work out okay. So now we have a 2% incidence rate. So out of these 10,000 people, 2% of them, or 200 of them, will have the disease. Meanwhile, the other 9,800 of them will not have the disease. Now, we have a false negative rate of 10%. And so that tells us that 10% of these 200 are going to incorrectly test negative. Meanwhile, the other 180 will correctly test positive. Meanwhile, we have a false positive rate of 1%, and that means that out of our people who don't have the disease, 1% of them, or 98 of them, are going to test positive. Meanwhile, the other, let's see, 9,702 of them are going to correctly test negative. So notice these here, these 98 people here, and these 20 people here are errors, right? So altogether, we have 278 people testing positive. So if we wanted to find out the probability that they have the disease, given that they test positive, then we have 278 people who tested positive. Of them, 180 have the disease, and that comes out to be about 64.7%. So about 65% of people who test positive, in this case, will actually have the disease. Now, there's another way we could go about this problem, and that would be using Bayes' rule. So let's take a look and see what that would look like. So Bayes' rule says that the probability of A given B is the probability of A times the probability of B given A over the probability of A times the probability of B given A plus the probability of A complement times the probability of B given A complement. Now, in terms of our disease, that would look like this. So now we can start filling in all this information. So, what is the probability that they have the disease? Well, that is, in this case, 2%, right? It's a 2% incidence rate. What's the probability that they get a positive test given that they have the disease? Well, there's a false negative rate of 10%, which means there's a 90% chance that they'll test positive given they have the disease. Down here, we got, let's hear again, probability of disease, probability of positive given disease, probability of no disease would be 98%. And then what's the probability that we test positive given that we don't have the disease? That's our 1% false positive rate. And if we compute all that out, it turns out to be 0.018 over 0.0278, which comes out to the same 64.7%. We came up using our nice little table. So this Bayes formula has its advantages, but for a lot of cases, working off the table like we did first is going to be a simpler approach.